Welcome back to the series Machine Learning using TensorFlow 2. In the previous video, we talked about what TensorFlow 2 offers for the training phase of the machine learning project. In this video, we are going to cover the next two phases. So when we're done with the training of our machine learning model and get our desired accuracy, it's time to utilize this thing. To do so, we have to save that model somewhere so we can utilize it later. Firstly, in the previous version of TensorFlow, it provides many options to save the model. But TensorFlow 2 standardized this thing by providing a standard format called saved model. The saved model can be loaded directly into your application from the local disk, or it can be uploaded to the production server for serving. Utilizing the saved model standard allows us to deploy that model on mobile, embedded devices, and the web also. The second option to save the model is the TensorFlow Hub. By using the saved model format of TensorFlow 2, we can share our pre-trained models on the TensorFlow Hub. Specifically, we can save the model by using the high-level keras model.save method, or we can save the model by using TensorFlow low-level APIs. As the name suggests, it's a repository of many pre-trained models. We can use transfer learning to reuse and extend these models to meet our requirements. Using pre-trained models gives us the advantage of training our model with a smaller dataset and quicker training. There are several considerations you should take into account while sharing your model on the TensorFlow Hub. The first one is, think ahead of time about how your model's consumers should fine-tune it, and provide guidance in the documentation. And secondly, choose a model interface that plays well with gradient flow, like output logits instead of softmax probabilities or top K predictions. Great. Now let's move on to the deployment phase. The best part of TensorFlow 2 is that you will be able to deploy the trained model on cloud or on premises. Not only that, using TensorFlow 2, you'll be able to deploy the model also on mobile devices such as Android and iOS, and even on an embedded device like Raspberry Pi. You will also be able to deploy the model on the web using Node.js. So according to these deployment options, we can categorize the TensorFlow offerings. First one, to deploy your model on cloud or on premises and serve it over HTTP REST and gRPC protocol buffers, TensorFlow provides the TensorFlow serving library. Then, to deploy your model on Android, iOS, or embedded systems like Raspberry Pi and Edge TPUs, TensorFlow provides a very lightweight solution called TensorFlow Lite. And lastly, the TensorFlow.js enables model deployment in JavaScript environments like web browsers or server-side through Node.js. Using TensorFlow.js, you will also be able to define models in JavaScript and train those directly in web browsers using keras-like API. At this stage, we are done with our machine learning model development. So we learned that what TensorFlow 2 offered us at each stage of the machine learning project development. I think that's enough for this video. In the next video, we will start writing code to explore TensorFlow basics. So if you enjoyed the content of this video, thumbs up, and be sure to subscribe to my channel and hit the bell icon so you will never miss any fantastic video in the future. Thanks for watching.